So case 2 is how can a ray diagram be used to determine the image how can a ray diagram be used to determine the image produced by a concave mirror when the object is just beyond the center of curvature. How can a ray diagram be used to determine the image produced by a concave mirror when the object is beyond the center of curvature? So here's our concave mirror. Here's the center of curvature. Right in between the two is the focal point. And this time the object is just beyond the center of curvature. And I'm going to have some of the object below the principal axis and some of the object above the principal axis. So again, that whole arrowhead right there, not just the top of it, but the whole arrowhead is the object. And that's always, sometimes students think that the object is like right there at the top where the arrow is pointing to, that point. But you can think of this as a person standing there, and this is their head, and this is their feet, and the whole arrowhead is the object. And what we want to do is figure out, where will the image be produced? Is it going to be a real image? A virtual image? Is it going to be smaller, the same size, larger? Is it going to be upside down, or is it going to be upright? And the good news is, we could just use some simple rays, those important facts that we just discussed in case number 1, to locate the image. So here's how it goes. I know, and I'm gonna erase this. I know that maybe light from the ceiling is shining down on the object, and then light from the object's head is diffused reflecting in all different directions. But I don't care about all those light rays reflecting off the object. I'm just looking to draw a few key light rays to locate the image. There's millions of light rays coming from the head of the object. I'm not going to draw all of them. I'm only going to draw key light rays that are going to help me locate the image. So let me get rid of all those light rays. Even though I know in my mind they're all there, I'm just going to draw some key light rays. And the first key light ray that I draw is a light ray leaving the object, the head of the object, and coming towards the mirror parallel to the principal axis. I know a light ray coming from the head of the object parallel to the principal axis. When it hits the concave mirror, I don't have to draw the little normal line, measure the angle of incidence, the angle of reflection to get the reflected ray. I know exactly how the reflected ray is going to go. How's that reflected ray going to go, Dorothy? Through the focal point. So then I just draw that light ray going. And you know what? I'm going to move my center of curvature back because on my diagram it wasn't quite perfect. However far back the focal point is, the center of curvature should be twice as far. Second light ray that I'm going to draw to help me locate the image, I'm going to draw a light ray coming from the head of the object that goes from the head of the object through the focal point and I know a light ray coming from the head of the object going through the focal point. When it hits the focal point, how's it going to reflect back, Dave? Parallel to the principal axis. Now, let me just erase this a little, make this a little smaller.
Is that supposed to hit the feet of the object?
No. It's not necessarily supposed to hit the feet, no. It may or may not. You know, by the way, that doesn't look very parallel, does it? Now, see if you can follow me. Here comes the big leap of understanding. The light really came from the person's head, right here. That's where the light really came from, yes? Okay. But if you put your eye, and I don't want you to draw this eye, but just see if you can follow me. If you put your eye right here, here's the person's eyeball. You know, like, you know, here's the eyeball, you know, and that's the nose and the mouth, you know. But I'm only drawing the eyeball. So there's the eyeball right there. If an eyeball, again, I don't want you to draw the eyeball. If the eyeball caught those reflected light rays, and it caught the light ray coming this way, and that went into the person's eye, and caught the light ray here coming from the person's eye, we know that the light really came from the head of the object and bounced off the mirror. Yes? But where would the person's eye and brain think that that light right there, these light rays right here, where do you think you would, your eye and your brain would think that that light came from? Right where they intersect. Your eye and brain would think that the light came from right there. You would end up seeing the person's head, this person's head right here, right here. The light really came from the person's head, bounced off the mirror, and went over here. And when the eyeball catches that light, where does it think that light came from? Right here. Now, I'm going to go ahead and also show you where the feet would be seen. So let me erase this eyeball here. And I'm not even sure if you want to draw this on your ray diagram because it gets a little bit messy, and I would just say watch this, okay? And I'm going to draw it in green. And I'm going to draw light rays, and you know what? I'm going to make the person's feet, go a little bit deeper here. So right there. Now, I'm going to use green light now to indicate the light, so we can distinguish between the red rays and the green rays. Although they're all light rays, it's not like I'm using different colors. It's just that I'm trying to show you, the light reflected from the head and the light reflected from the feet. So again, to indicate light in this next little segment, I'm going to use a green colored pen to indicate where the white light is. And once again, white light is going to be shining down on the person's feet, and it's going to be diffused, reflecting in all different directions. And I'm not going to draw all those light rays reflecting off the person's feet. I'm just going to draw a couple key rays. So if I draw a light ray coming from the person's feet, coming, not very nicely drawn, let me try that again, coming parallel to the principal axis, how would that light ray reflect? Light ray coming from the person's feet and hitting the curved mirror, how is that sucker going to reflect? Through the focal point. A second light ray. Second light ray going through the focal point. Remember, there's the focal point right there. Whoopsie. Back to green. How's that light ray coming from the person's feet? How's that going to reflect off the mirror, Dave? Parallel to the principal axis. And again, let me just make these green rays a little bit shorter here. Now, once again, here are the light rays that got reflected off the mirror that originally came from the person's feet, yes? Now, if I had my eyeball right here, and my eye was going to catch those light rays coming right here and right here, once again my eye would be faked out, and even though you and I know that the light really came from the person's feet, reflected off the mirror, went this way, and another ray came here and reflected off of there and came that way, where would your eye and your brain think that that light is coming from? The intersection, right there. So notice, folks, the head of the person is seen here. The feet of the person is seen up here. We just located the image. Now, you see how we did the whole process with the red rays for the head and the green rays for the feet? That makes the diagram so messy. So to save time, we're going to redo this in a moment, and we're going to put the feet right on the principal axis. And when the feet are right on the principal axis to begin with, then they're right on the principal axis where the image is. So we're going to redo this in a moment, but before we go there, what's something you could say about this image right here? And you know, and I should kind of mark this out. Right there, wah, 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 wah. That whole thing right there. That's the image. Notice anything, you know, we could say about that image? It's upside down. Excellent. Inverted. Notice anything else about the image? It's smaller. And the third and final thing we have to note, there really is light there. Look. We really have light right there. There actually is light right there. And there really is light coming right through there and right there. We could put a little screen right there, and we could see the image on a screen. So what does that mean, Dorothy? It's a real image. So instead of drawing the ray diagram for the head and the feet, too confusing. Okay? From now on, we're just going to draw ray diagrams for the head of the object. And we know that the feet, when they're on the principal axis, the image's feet are going to be on the principal axis. So let's go and draw it again, more simplified version. Concave mirror. Focal length, center of curvature. But now I'm going to draw the object with the feet on the principal axis. And if I want to locate where the image is going to be produced, I'm going to draw two important light rays. Because I know exactly what these two light rays are going to do when they hit the mirror. What's one of them, Dave? What's the first light ray that I'm going to draw?
Goes to the focal.
Actually, that's my second one.
It's the mirror. Looks parallel to the
Parallel to the principal axis. All right, we're going to draw a light ray parallel to the principal axis. And we know for a fact, Jack, that light ray is going to go back through the focal point. Let me make that arrow a little bigger. And Dave, what's the second ray I want to draw? Through the focal point. And what is that light ray going to do? It bounce back parallel to the principal axis. And where the two intersect, that's where the image's head is located. So this is the object's head. Womp, womp, womp. I just located the image's head right there. Now, here's like the easy part. You see right here, that's the feet of the object, and they're on the principal axis. Well, if I come over and I look at a line going, straight up like that, the feet are going to be on the principal axis at that same distance that the head is from the mirror. So if this is the head of the image, I know that the feet of the image are going to be right on the principal axis, right where the head was formed. So now I could go back and I could fill it in. And that's the simplified version. That's the standard. That's what you will see in the textbook. In the review book, this is the picture they'll show you. The image produced. And of course, it's real, smaller, and inverted. Now, I don't want you to draw this. I'm just going to show you this, and then I'm going to erase it. But remember, we only drew 2 key light rays, yes? But here's the interesting thing. All of the light rays coming from the object's head, watch this, that hit the mirror, guess where they will all go through? Say another light ray going through here. Whoopsie, I don't want to use that color. Another light ray coming from that object's head. Of course, I'd have to measure the law of reflection, blah, 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 blah. But you know what? Guess where that light ray was going to go? Right through that same point. Another light ray that came up here. Where would that sucker, how would it reflect? Right through there. Another light ray going over here. How would it reflect? Right there. All the light rays would go through that point right there. Now, but we don't draw all those light rays. We don't care about the fact that all those light rays. We only draw the 2 easy ones that help us locate where the image is going to be. But the truth of the matter is, all these light rays would hit the mirror, obey the law of reflection, and go through that point down there. But the standard diagram, we just showed 2 of the rays. Okay? Alright, so let me pause here.